our sun is one of just the 100 billion stars in our Milky Way galaxy, and scientists have predicted that there are over 100 billion galaxies in the observable universe. There are more stars in the observable universe than there are sand particles in all Earth species combined. So like, people should care about this stuff more, like what she just said. Like, it's surrounded by us 24/7, and people don't really know how vast and big it is. And so like, whenever I get the chance to inform people about it, I'm obviously going to take it. Throughout my entire life, I've been obsessed with astronomy. I have my own telescope. I got into astrophotography, and I even almost went to Michigan State to study astrophysics. So the next couple minutes, I'm going to be starting off by talking about the measurements that are used in outer space. I'll then continue to talk about our Earth and our solar system, and I'll finally finish up by talking about how big our observable universe is. So whenever talking about something so big, you must begin with the basics. So there are actually many ways to measure outer space, but one of the best ways to measure, and what scientists use the most, is called a light year. A light year is the distance it takes for the speed of light to travel in one human year, which is 6 trillion miles. So, let me break this down for you. If I turn on a flashlight and I held it in the same place for a single year, the photons, which are light particles that are coming out of the flashlight, would be 6 trillion miles away from the flashlight from the moment I turned it on. So there's no way we can measure outer space using like feet, meters, yards, etc., because the numbers would be way too big and complex for even us to understand. Another great way to measure outer space is an astronomical unit. An astronomical unit is relatively the distance between the Earth and the Sun, which is 93 million miles. Since 93 million miles and 6 trillion miles don't compare, we usually use astronomical units to measure our solar system and like relatively smaller distances between planets than like to measure our observable universe. So now that we've talked about the measurements, we can finally go on to our own Earth and our solar system. So Earth is the third smallest planet in our solar system, and according to Dr. Luke Davies, a University of Western Australia astronomy professor in the Science Network section, Earth's radius is 4,000 miles, while Jupiter, the solar system's biggest planet, is 44,000 miles. Although it's the third smallest planet in our solar system, it is the biggest of the terrestrial planets. So the terrestrial planets are Mercury, Venus, Earth, and Mars, the first 4 planets close to the Sun. They're the rocky ones because they're close to the Sun. They actually have a core, unlike the 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, that don't even have a core. They're all made up of gases. So we're only going to get bigger here. The diameter of our solar system is 80 astronomical units. So that's roughly 7.4 billion miles. On an even bigger scale, the Earth and the solar system lie in the Milky Way galaxy. The diameter of the Milky Way galaxy is 105,700 light years. If you do the math, the Milky Way galaxy is 4.12 septillion times bigger than our solar system. And the farthest yet that humans travel is to our very own, which is 250,000 miles away from Earth. So it's pretty crazy to think about. So now we're going to jump on to we're really going to emphasize what makes us super small. So our observable universe is 93 billion light years in diameter. To put this into better perspective, if 1 light year is 6 trillion miles, and you multiply that by 93 billion miles, or 93 billion, you get, oh, you gotta be kidding me. That was supposed to be super emphasized, but alright. So that is how big our observable universe is in miles. I couldn't tell you that exact number, I have no idea, but I did the math and it came out to that number. So it was 5.58 times 10 to the 23. So there's so many more crazier things that are in space, like quasars, pulsars, black holes, and like all the theories that are really weird. So, but the craziest part about all this is that our universe, observable universe, is still expanding. According to the Adam Rees of the Space Telescope Institute and Johns Hopkins University, our universe is expanding at a rate 5 to 9% faster than the speed of light. Scientists are still trying to figure out how and why this is happening, and yet they still don't know why. So within these last couple minutes, I talked about the measurements that are used in space, our Earth and our solar system and our galaxy, and I finally finished up by talking about our universe. So I get that all this is kind of like hard to take in within the, like, just from a speech. So like I'm gonna leave here with like one note that would really get you thinking. So when you go up at night and you look at the night sky, right, you see all those stars. The stars that you look at are billions and millions and trillions of light years away from you. So if it takes trillions and millions and billions of years for that light to reach your eyes that is coming off that star, you are technically looking to the past. Any questions? Yeah.
Are there any negative implications for the expansion of the fact that the universe is expanding?
What do you mean?
Like, if it keeps expanding, is anything
So,
bad gonna happen?
Well, you know how like there's the Big Bang, right?
Yeah.
So there's a theory that it started all the way back from when Albert Einstein was in his work. There's a theory that it all started off as a Big Bang that's basically like a big rubber band. So it keeps stretching out, and then eventually it will collapse back in and form what is like technically another Big Bang. So, but like that's just a theory again, but it is expanding 5 to 9% faster than the speed of light. And the speed of light is the fastest thing that we have to measure. So I mean, it's weird to think about.